So in this video, I'm going to be talking more about complex numbers. Now, if you watched the last video, you'll know we talked about what is I and the different basic operations using I. But now we're going to be talking more about using I in equations and finding solutions of equations which have I in it. But first, little follow on from last video is what is the reciprocal of a complex number? Now you have, let's say you have z, which is x plus iy, and you want the reciprocal of it. So what we'll do is just write it in its general form. Now again, if you remember from last video, if we want to get rid of the I on the bottom, we have to rationalize it, basically. And to do that, we times by the complex conjugate. So here we want to times top and bottom by x minus iy. Then let's move it down here. The top will be just x minus iy. The bottom will be x squared plus y squared. Again, seen from last video that x plus iy times x minus iy just cancels down nicely to x squared plus y squared. So this also means that 1 over z can be written as z star over the modulus of z. Now this also means that we can write the 1 over z as z star over the modulus of z squared. So usually when we get given real equations with real solutions, we would solve it like this, where we move the 49 over to the right side, so plus 49 on both sides, and then square root 49 to give you plus or minus 7. Or another way you could do it is by factorizing, because this is what is it, sum of perfect squares. You get x minus 7 and x plus 7. So then from there you can see that the answer is going to be plus or minus 7. But here we have a bit of a problem we run into, because we minus over the 49 and we are going to square root the minus, which is using real numbers impossible, but because we're using imaginary numbers, it's very possible. When we're square rooting, one way you can do this is just first of all by doing that, then separating the minus from the 49. So we have square root minus 1 plus or minus square root 49. Now this is an easy way of visualizing it, because square root of 49 is simply just 7, and then here you have times plus or minus I, because we know what square root of minus 1 is. So the answer for this one would be plus or minus 7i. And factorizing this, you're going to just get x minus 7i and x plus 7i, which from there you can see the answer is x is plus or minus 7i. So here is an example. X squared plus 4x plus 5 equals 0. Now to solve this one, we're obviously going to need imaginary numbers, because let's say if we were to just try and use real numbers, we want two positives or two negatives to multiply to make plus 5. So that's obviously going to be 5 and 1, because we want to try and make this 4. But if we wanted to make the 4, then we'd need a plus 5 and a minus 1. However, plus 5 times minus 1 is minus 5. So the way that we solve this is using the good old quadratic formula. So we'll sub in our values for B, A, and C. So there we have minus 4 plus or minus 4 squared. Or actually, I'll just change that to 16. Minus 4 times 1 times 5, which is 20. Over 2 times 1. So we have a real part, which is minus 4 over 2, and then we have plus or minus root minus 4. So if you remember from earlier, let's do the minus 4 over 2 is just minus 2. Then plus or minus, to separate the minus 1 and the root 4. So then we can easily see that that turns into an I times 2. So the answer is minus 2 plus or minus 2i. So here we have another example. Show that z equals a half and 2i are solutions to the equation 2z cubed minus z squared plus 8z minus 4 equals 0. And also, are there any more solutions? Now, there's a few rules that you will come into with complex numbers, and one of them is when you're working with quadratics, let's say, you either get, when you have all real numbers in your quadratic equation, you either get two real solutions or two imaginary solutions. When you're working with complex numbers and all of your numbers are real as well in your cubic equation, you're going to either get all real solutions or one real solution and two complex numbers. Now, this is where the second rule will be coming in handy. But let's first show that these two are solutions. So we'll sub it into the equation. Let's call the equation P of Z. Let's actually write it down there so it's a bit easier to see. So we'll sub in Z equals a half. Now cubing a half gets an eighth, so 2 over 8. Squaring a half gets a quarter. 8 times a half is a 4, and then minus 4 in the end, so we can see that them two are going to cancel out. And 2 over 8 is a quarter, minus a quarter, which cancels them out again, so it equals 0. So we've shown that half is a solution. Now let's put 2i into here as well. So here we have 2 cubed, which is 8, but then we've got I cubed as well. So 8 times 2, first of all, is 16. Then we got multiplied by I cubed. Let's just leave it like that for now. Minus 2I squared. So 2 squared is 4. I squared is minus 1. So times by minus 1. Plus 16I minus 4. So I squared is minus 1. So this first term will cancel down to minus 16I. Then we have minus 4, which turns to plus 4. And then we have plus 16I minus 4. So plus 4 minus 4 cancel. Minus 16I plus 16I cancel. So equals 0. So that's, again, showing that 2I is the solution to this equation. Now, there's a question, are there more solutions? So, when there is one real solution and another complex solution, the third complex solution, or sorry, the second complex solution, but the third solution will be the complex conjugate of the imaginary solution we have here. So, answer to that is third solution equals minus 2I.